Hi everyone. Today we're going to study one-way analysis of variance. One-way analysis of variance is sometimes called one-way ANOVA. One-way ANOVA is used to compare several means, that is, more than two means. The analysis of variance that is used to compare three or more means is called one-way analysis of variance, since it contains only one independent variable. In this case, we are using f-test and not several t-tests. There are assumptions for the f-test for comparing three or more means. Number one, the populations from which the samples were obtained must be normally or approximately normally distributed. Second, the samples must be independent of each other. Third, the variances of the populations must be equal. Here is a note. Even though we are comparing three or more means in this use of the f-test, variances are used in the test instead of means. Here is now the f-test for one-way ANOVA. For the test of the difference among three or more means, this is the step 1. State the hypothesis and identify the claim. So here is how we're going to write the hypothesis. The null hypothesis, denoted by h sub 0 colon mu sub 1 equals mu sub 2 equals up to mu sub n, where n here is the number of means. While the alternative hypothesis, denoted by h sub 1 colon, we say that at least one mean is different from the others. Step 2. Find the critical value. The critical value is obtained from Table F distribution. In finding the value, we must first compute for degree of freedom of numerator, denoted by dfn, and this is equal to k minus 1. This k is the number of groups. Another degree of freedom of denominator is required, and this is denoted by dfd, and this is equal to capital N minus k. This capital N is the total number of samples. Step 3. Compute for test value. The f-test is the ratio of between group variance to within group variance, and this is denoted by this formula. F equals S sub B square over S sub W square, where S sub B square is the between group variance. The formula is S sub B square equals the summation of n sub I times the quantity x bar sub I minus x bar sub gm, and this quantity is squared all over k minus 1. K is the number of groups, and GM is the subscript here that means the grand means. The S sub W square is the within group variance. The formula is S sub W square equals, the numerator is the summation of the quantity n sub I minus 1 times the quantity S sub I square all over the summation of the quantity n sub I minus 1. N sub I is the sample size of each group, while the S sub I square is the sample variances. Step 4. Make the decision. Reject the null hypothesis if the computed value is greater than or equal to the critical value. When we say computed value, this is the test value. Or accept the null hypothesis if the computed value or test value is less than the critical value. Step 5. Summarize the result. We write the conclusion based from step 4. Let us see this example. A researcher wishes to try 3 different techniques to lower the blood pressure of individuals diagnosed with high blood pressure. The subjects are randomly assigned to 3 groups. The first group takes medications. The second group exercises. And the third group follow a special diet. After 4 weeks, the reduction in each person's blood pressure is recorded. At alpha equals 0.05, test the claim that there is no difference on the means. The data are here. For medication group, the values are 10, 12, 9, 15, and 13. For the exercise group, the values are 6, 8, 3, 0, and 2. For the diet group, the values are 5, 9, 12, 8, and 4. Now let us write the step 1. State the hypothesis and identify the claim. The null hypothesis is H sub 0 colon, so we write mu sub 1 equals mu sub 2 equals mu sub 3. The alternative hypothesis is H sub 1 colon, and we write at least one mean is different from the others. When we read the problem, we can see that the null hypothesis is the claim of this problem. Step 2. Find the critical value. We identify that k equals 3. K here is the number of groups. Capital N, the total number of samples, equals 15. And alpha is given in the problem as 0.05. The degree of freedom for numerator is equal to k minus 1. K is equal to 3 minus 1, so we have 2. The degree of freedom for denominator is equal to capital N minus k. So we have 15 minus 3 equals 12. So the critical value is 3.89, and this is obtained from Table F distribution. Step 3 is to compute for f-test value. At first, let us find the mean and variance of each sample. We know that x bar, or the mean, is equal to the summation of x over n, and the variance is equal to the summation of x minus x bar, and this is squared, all over n minus 1. Computing for the mean for each group, we have now 11.8, 3.8, and 7.6 respectively. While the variance, we have 5.7, 10.2, and 10.3 respectively. Now for step B, find the grand mean. This is the mean of all values in the samples. Formula is x bar sub gm is equal to the summation of capital X all over capital N. So what we're going to do is to add all these raw data from the first up to the last number and divide by the total number of samples. And the value is 116 over 15, and this is equal to 7.73. Step C, find the between group variance, denoted by S sub B square. And the formula is here. Substituting the corresponding values, we have now this 5 times 11.8 minus 7.73, and this quantity is squared, plus 5 times the quantity 3.8 minus 7.73, and this quantity is also squared, plus 5 times the quantity 7.6 minus 7.73, and this is also squared, all over the k minus 1 now becomes 3 minus 1. Simplifying our numerator and denominator respectively, we have now 160.13 over 2, and this is equal to 80.07. Let us copy this value on this side, and let us proceed with the next step, and that is step D, to find the within group variance, denoted by S sub W square. The formula is here, and let us do the substitution respectively. So this is equal to 4 times 5.7 plus 4 times 10.2 plus 4 times 10.3 all over 4 plus 4 plus 4. Simplifying the numerator and denominator respectively, we have now 104.80 all over 12. And the quotient here is 8.73. Now for step E, to find the f-test value. Our formula is here, so let us do the substitution. This is equal to 80.07 over 8.73. And the quotient is 9.17. For step 4, we will make the decision, and we say that reject the null hypothesis, since test value is greater than the critical value. In symbol, we write 9.17 is greater than 3.89. That is, the test value falls in the critical region. For step 5, summarize the result. And we say that there is enough evidence to reject the claim and conclude that at least one mean is different from others. This is our final answer. I hope you learned something from this video. See you again next time.